Okay, I think that one of the best feelings for us as a software engineers is when we merge our changes to the main or master branch. Everything goes smoothly, and within the minutes, the changes are working in the production. However, sooner or later, we are the people in charge of building the deployment pipeline, infrastructure, and everything around it, probably sooner because of the AI. And that's less fun sometimes, usually quite challenging, because there are so many things to take into the consideration, including scalability, security, performance, traceability, observability, and all that stuff. And I think back then, when we were thinking about the Rails deployment, Heroku was one of the most common cases to run the infrastructure. But these days, this is no longer the case because we have so many other options we can choose from that is better cost-wise and operations-wise. And in this presentation, I will show you a few choices that you can make with the Docker and Rails in the production to run the whole infrastructure. But before we start, just a quick introduction from me. My name is Paweł Dąbrowski. I work at Medihive as a tech lead, where we are building the world's most trusted telemedicine provider. I also build engineering teams there. We are hiring, so if you are interested, you can join. And I also work with Arkansas as an AWS architect. And of course, I learned DDD from the Masters of the Craft. And when it comes to deploying, I think I did my first deployment around 2010. And since that, I learned a lot of lessons. I made a lot of mistakes. And based on that experience, I prepared 4 options that you can consider when running your Rails in the production. And to make it a little bit easier for you to decide which option may work for you, I created a simple decision framework. So these 10 steps I will be using during this presentation to compare the options and to show their characteristics. So let's start with the very first one, with Doku. So Doku basically is an open source Heroku, is a platform as a service, quite popular on GitHub, quite actively maintained, around 28 open issues, so that's a good sign. And Doku is basically great if you want to run a small application. Let's say you want to run a blog, hobby application, proof of concept, MVP, internal tool, everywhere where you can accept the risk that your application will go down if the server is going down, because there is no horizontal scaling in Doku. And when it comes to environment preparation, of course, you have to select the server. These days, Hetzner is probably one of the best choices when it comes to price and quality. Then we need to configure our SSH key and install Doku. Doku comes with the built-in installer, so it's really easy to install everything, including Docker. And it takes around 5 to 10 minutes on average to have everything working. And then you have to create a virtual environment for your application, set the environment variable, and configure the database. As you can see here, you can do that with the plugins. So in Doku, we have the concept of plugins. We have plugins maintained by Doku maintainers, which are great. And we have plugins maintained by the community. These are also great, but sometimes not that much. And we have to configure then the database by creating the database and linking it with our application. And thanks to this link process, automatically the environment variables are added to our application. So it's really handy. And then, of course, we configure the domain. It takes just one DNS record to point to the server, and it will be working. Configuring SSL can be also done with the plugins. Within seconds, we can have a certificate with Let's Encrypt. And then the application preparation. So it's like a Heroku. So in many cases, you don't need Dockerfile because we have build packs. Doku will automatically detect your tech stack and prepare the build. But if you want to have more control over it, or your application is more like complex, then of course you can configure Dockerfile and Docker image. And in terms of processes, we have to define the Procfile, which is also known from Heroku. We tell Doku what kind of processes we would like to run. Well, the deployment workflow, the same as Heroku. We add Git remote, and then we just push, and everything is building. And the cost structure, so the base unit is really the server, right? But if you want to run database outside the server, then you have to take it into account. But on the base setup, Doku is just a VPS, so it's like $7, I think, $8 for a small application. The learning process, there is not much to learn. Basically, you need 5 minutes to familiarize with the Doku commands. And then, of course, if you have Heroku experience, then you feel like home, you know how it's working. The advantages, the obvious one, the low cost, because for a cost like few euros, we have a working server. Fast configuration, because within the 15 or 20 minutes, we have everything working. And the plugin ecosystem, as many like resources like Redis, Elasticsearch, or database are really easy to install and configure. The disadvantages, there is no horizontal scaling. So if your server is failing, then the application is not working. The operational burden, because you have to take care of everything, including all the resources like database or the Redis. And some more effort is needed for zero downtime deployments. There is a configuration file for that, but you need to spend some time taking care of it to make everything work as expected. The things to be aware of. So logs don't persist between the deployments. So as soon as you do your next deployment, your logs are gone. Doku comes with the support for Vector. Vector is an open source solution for managing logs and sending them to different destinations like CloudWatch. So you can use that, but it's something you have to remember about when configuring. Periodic resource cleanup is required because between the deployments, some resources are left. And depending on the number of the deployments, after a few months, you can run out of the disk space. So that's something you should be aware of. No automatic backups by the default. You have to enable it with the plugin. There is a great plugin for S3 and periodic backups. SSL renewal requires manual configuration. Once you enable the certificate, of course, it will expire after some time, so you have to configure it explicitly to renew it every single time instead of watching it. And of course, access Rails console with existing containers. I saw some people that they were spinning new containers just to access the console. So that's something we would like to avoid, just to not create, unnecessary resources. And of course, the AI assistance opportunities. If you are running multiple applications with Doku and you have a big server and you really want to use AI, maybe MCP will be a good fit for you. But besides that, you can, of course, get assistance with the Dockerfile creation just to improve the security and reduce the image size. And you can get some configuration review and hardening of the Nginx just before going to the production. And the next option is Camel, quite popular these days. This is an open source solution provided by Basecamp. So it's basically Capistrano for containers. And I really feel the vibe because they both using SSH-kit. So when you watch Camel logs, you have the feeling like you are running Capistrano. So that's very familiar. And Camel is very flexible. It's great for smaller apps. It's great for larger apps, also internal environments. Basically everywhere where you can accept the cost of over-provisioning for the potential higher traffic, because there is no auto-scaling yet process because of the nature of the Camel. And when it comes to environment preparation, it's as simple like installing the gem, invoking the Camel init, and it creates 3 files. The first one is the server configuration. Then we have a secrets, so the credential we would like not to store in the Git repository, but we want them on the server, and we have hooks if we want to extend our deployment with our own workflow. It also starts with the server selection. Again, Hetzner or something similar will be also great for smaller setups. Before we do the deployment or the setup, we need to log into the Docker registry. That might be a little bit annoying, but we have to do that. And then we can invoke the Camel setup. And it will configure everything on the server, including the Docker. And here is the sample configuration for the deployment. We have few sections that are here. We have the image name that also will be present on the Docker registry. We have the list of our servers. We can use the domain and the SSL, so we have to define the proxy. Camel also uses Let's Encrypt, but it's even more easier to configure it then with Doku. We have some builder arguments, of course the registry, just to show Kamal how we can pull our Docker image on the server, and the environment section with the clear subsection where the non-sensitive environments are defined, and we have secrets where we load the secrets from the file. We also have the concept of accessories. These are our site resources for our application, for example, the database. So we also can provision that really easily with our application. When it comes to preparation, we need Docker file. Otherwise, Kamal don't know how to build the application. The deployment workflow, if we have a single environment, then it all comes to only one file. We invoke Kamal deploy, and everything is deployed. But if we have multiple environments, we'll end up with having one file per environment, and then when you deploy, you have to provide destination flag with the name of the environment. The cost structure. So the base one is, of course, the server, but we also have to take into consideration the image registry. One of the common choices is Docker Hub, but there is only one private registry for free. Another thing is AWS ECR, where you pay for the storage and for the transfer. So these are the base costs. If you would like to run multiple servers, you will need load balancer, so this is an additional cost. And then the shared database, because we have multiple servers as well. The learning process, the core concept with the Docker, which is obvious. The configuration, so it takes some time to get used to the declarative way of configuring the deployment. And then we have accessories. Of course, accessories are part of the configuration, but they are not working the same as Race application, so we have to put some more attention to this to avoid some kind of downtime for our database, for example, when we are upgrading the image. The advantages, low cost, we can run it everywhere, flexible setups. You can run Rails along with the database on one server. You can have database on a separate server. You can have multiple Rails instances. It all depends on your specific case. And simplicity, because we have configuration file that is very readable, and you look at it and you know what's going on there. The disadvantages, there is no auto-scaling. That's why you have to over-provision the resources if you expect more traffic. If your traffic is not predictable, then probably you should consider other options, because there is no point in provisioning 5 servers, for example, if you don't need this. You are the DevOps, so you have to take care of the resources and everything around it. And it requires some experience and some time. And there is no built-in monitoring and logging, so you have to configure it explicitly. And the things to be aware of, you don't have to SSH to the server. You can just use Kamal app exec and, for example, trigger the console or any other action. It will be great if you care about the Docker image size, because it will influence the cost that you have on the Docker registry. It's good to pioneer base image version just to avoid different image version in the production and in the staging. When you use the latest stack, it can happen. Take advantage of per branch staging environments, and this is something we do at Medihive. So basically, instead of one big staging servers where developers are waiting for their return to test with the QA, each developer starts their own branch, and they create dedicated environment with the dedicated URL where the branch is in the name. So that's really useful when you have multiple QA processes running in the same time. And it's really easy to do that with Kamal and some scripting on the server. And then you can consider proxy server for the deployments, because as I mentioned before, you have to log in into Docker registry before deploying. That might be a little annoying, but if you have proxy server, your developers doesn't care about that, and you have additional layer of security, because you can just reject the access to the server if person shouldn't have access to the deployment. The AI assistance opportunities, you can translate Docker Compose to Camel config. It's quite easy, and again, you can get some assistance with Dockerfile creation if you want to improve it for your setup. The next option is Elastic Beanstalk. This is the first service in the AWS cloud. So basically, Elastic Beanstalk is the fastest way to get your application run on AWS without extended configuring. It's great for smaller apps, it's great for bigger apps because there is auto-scaling and you can easily run one small application on small instance or a few instances that are bigger. Basically, you can consider Elastic Beanstalk if you know AWS environment a little bit and you're fine without having the full control over it because Elastic Beanstalk is doing some stuff for you. The environment preparation is basically updating few forms. This is the example of the environment details. So we have 3 sections. We have environment, the basic details, which is the application name, the environment name. We have the platform. There is a dedicated Ruby platform on the AWS, but I wouldn't advise to use it because then it's harder to upgrade it. It's more risky. And there is a Docker platform, which is very flexible. And the app code, we should basically deliver a zip archive to the Elastic Beanstalk, so we can do that through the S3 or just uploading it directly. Then we have the infrastructure. The tier is web environment or worker environment. If you plan to use, for example, Sidekick, but you want to run it on the Rails instance, then you go for web environment. But if you want Sidekick instance on a separate server, then you have to define the worker environment for the Sidekick and the web environment for the Rails. We have auto-scaling options. Compute is the instance size and the params, and we have a little bit of networking because we have to ensure that our setup is secure and other people can reach it from the internet. The application preparation depends on your setup. We have a single container, so we need just a Docker file, but if you have other processes, you have to also provide Docker Compose because this is the way Elastic Beanstalk would know how to run your application in the cloud. We also have the concept of platform hooks. If you want to extend your workflow, there are 2 ways you can deploy your application with Beanstalk. You can do this automatically via command line. There is a ignore file where you list all the files you would like not to have in the archive, or you can do it manually with creating the archive. Just remember to not put there node modules or anything like that because the size of the archive will be really big, and then you just upload to Elastic Beanstalk and it's deployed. The cost structure is more complex compared to Doku or Camel, so the mandatory services are EC2 because they are instances for the server, RDS for the database, S3 to keeping the archive of the application. It's also needed because without it, there is no way to do the rollback. Because of that, Elastic Beanstalk knows which version belongs to which file. And optionally, if you plan to run multiple servers, you will need load balancer. If you need Redis, then Elasticache. If you need manage the domain, then Route 53 and other services depending on your needs. The learning process, core concept with the Docker, some AWS fundamentals because you have to know how to navigate on the AWS, and then just a little bit of networking and security to not allow anyone to, SSH to your server or read your secrets. So that's the minimum you have to do. The advantages is easy to get started when we're talking about the AWS. Auto-scaling out of the box, there are like standard metrics you can use to auto-scale your servers. And of course, integrated with AWS ecosystem, it's much easier to connect different services with Elastic Beanstalk. Disadvantages, limited control because Elastic Beanstalk is managing some processes for you, so you don't have to access to it. Painful debugging. When the deployment is not working, you have to explicitly trigger the logs to be generated. Then you have like 15 files of logs, so it's kind of painful to review them and find out what is not working. Slow deployments with one instance, it will take around 4 to 5 minutes, of course, depending on the size. But with multiple instances, it will take like 15 minutes or more, and it's quite slow. And of course, we have the vendor lock-in because we are in the AWS cloud and we are using all the services. Things to be aware of. Use dedicated database and load balancer. Elastic Beanstalk really wants to use those automatically generated, but it will be difficult to migrate out of the Elastic Beanstalk with those automatically provisioned. So it's better to spend some time creating them and then attaching. Increase disk size from the start. By the default, there is like 8 gigabytes available, but it's not enough to build the image, so 20 gigabyte would be fine for the start. If you want to run your like Sidekick or any other process separately from the race instance, you have to define worker environment separately. Use ECR and benefit from image layers caching. So this is something we recently did with Arkansas. The deployment was really slow, and we introduced layer caching. So with every deployment, the caching is reused, and only those layers that are changed are added to the caching. So it reduced like 40 to 60% time needed for the deployment. And if you are using ECR, which is Elastic Container Registry, you have to use policies for storage cleanup. Otherwise, you will end up paying for the images that were created years ago. And this is something we would like to avoid, of course. The AI assistance opportunities, debugging via log review. AI is really great for that. It can grab all the files and within the minute tell you what was the reason why your deployment failed. Of course, assistance with the Docker file creation, but also we can get some support with CloudFormation template generation. If your policy required you to have a possibility to recreate the whole environment from the bottom, then there's really good help, because with CloudFormation you can provision the whole infrastructure with one template. And the last one, the most advanced one, is the Elastic Container Service. So you can treat it like a Kubernetes alternative that is just simpler. So it's fully managed container orchestration service for deploying, managing, and scaling containerized application. It's better for more complex apps like microservices or multi-service, where you have like Node.js APIs or Python APIs running next to your race application, and you have to communicate with those components via the internal network. So if you want a container orchestration without managing the server, and you are fine with higher per unit cost and AWS-specific configuration, this is the solution you should look for. The environment preparation, unfortunately, starts with some networking, so you have to create VPC, define the subnets, security groups, and then we have this specific configuration for ECS. So we have a cluster. Cluster is like a virtual boundary for our application. Then we have to create task definition. So you will have one task definition for a race application, another one for DB migration, and another one, for example, for Sidekick. If you want to run just the task and finish it, like DB migration, you create just the task. But if you want to keep it running like the server, then you have to create the service. The service is in charge of coordinating all the stuff. And then, of course, we have a bunch of services that we need to use, like ECR for keeping the Docker images, RDS for the database, load balancer to split the traffic, and all other services that are very specific to your setup. When it comes to application preparation, it starts with the Docker file, but it will be great to store the task definition in the code base, because it's infrastructure as a code. You don't have to log into AWS to change something. You see the version of the tasks, so it's really beneficial to keep them in the code base. And the deployment workflow is basically usually triggered by CI. You build the image, then you push it to the registry, you get the new ID, so you have to update the task definitions. And then, depending on your process's nature, you either run tasks like DB migration, which is running and then finishing, or they deploy the task to update the service that handle the race server, for example. The cost structure, that's the place where it becomes very pricey. The basic unit is task, where you define how much RAM or how much CPU you would like to use. Then you know what is the price for an hour. And then on top of that, you have to add other services like RDS, S3, and it can generate a lot of costs. Comparing to the Elastic Beanstalk, the same instance size will be like more expensive, 2 or 3 times even, so that's really high. The learning process, we have the core concept with the Docker, some AWS fundamentals, networking and security, because we have to configure everything to connect to the real world. And then we have this specific AWS ECS configuration, the cluster task definition, task, and service is still a lot simpler than Kubernetes. What are the advantages? The simple mental model compared, of course, to Kubernetes. The native auto-scaling, it works really great. There are a lot of metrics you can choose from. Of course, you can define your own one, integrated with the AWS ecosystem. When it comes to disadvantages, it's really opinionated and closed. You cannot extend it with some open source stuff. You have to deal with the way AWS designed it. The cost can be really high, so that's also disadvantage. And the ultra vendor lock-in is also definitely the disadvantage. The things to be aware of, as I mentioned before, it's better to keep tasks definition as JSON in the code base, benefit from image layers caching on ECR, just to reduce the deployment time, then use ECR policies for storage cleanup to not keep the old images on the registry because that also costs money. Retention policy for CloudWatch. With many containers, you will have many logs, so you would like to avoid situation when you store all of them for all the history of your application. So that's another place where usually there is high cost allocated for many applications. And use custom metrics for auto-scaling if it makes sense. In terms of Rails, it's usually better to use like Puma pool size instead of CPU or some other metrics. So that's something we should be definitely looking in when configuring that. And when it comes to AI assistance opportunities, of course, we have assistance with the Docker file creation. We can easily translate Docker Compose to Dask definitions if we are migrating from some other solutions. And the most common issues with AWS are networking, so AI is great with telling how to solve some issues, why some services are not responding, or why I cannot access my Rails application outside my network. Yeah, and so that's basically it. Thank you. Any questions?
Okay. Thank you for the presentation. I really enjoyed it. Could you tell a bit more about your experience with stolen CloudWatch logs that contribute to higher costs? Is it that it's us developers shooting us in the knee by polluting the logs with unnecessary data, or and how to get around that? Only to log some certain things to CloudWatch, some tips to avoid?
Yeah, that's a great question. So putting unnecessary data in logs, it's something we should always avoid, right? Because it creates like harder debugging sessions and it takes place. But basically, with CloudWatch, for example, depending on your company policy, but if you need to store logs for 1 year, then store them just for 1 year. If you forgot about the retention policy, you can store logs for like 5 years in the past and then create just basically costs that you can easily avoid. So that's something I would recommend. Basically, log only meaningful stuff and then keep the logs only for the time period that is necessary. So these are the two things that will solve you a lot of headache in most cases, I believe.
Follow-up question: would it make sense to, if you got these retention periods relatively long, would it make sense to port it, move them and store them elsewhere in order not to overpay AWS, or does that not sound like a real use case?
Yeah, we can just move it to S3 to some like options that have lower cost because you least frequently access them. So you can pack them into one zip archive and just put them on the S3 bucket with the lower cost because you do not access them frequently, right? It all depends on your need. If you don't need them and you know that you can wait like 1 hour, 1 day until you get them just for auditing purposes, then go ahead for the S3 storage with the classes that are meant to handle those cases when you don't need them.
Excellent.
Thank you very much. Oh, there is one question at the back.
thanks for your talk. A simple question, because you mentioned you have made a lot of errors during your learning process. So I was wondering, what was the maybe some failed experiments of yours? Like, I don't know, clickers, or I'm not sure. Something like that. Could you share your experience?
Yeah, one of the failed experiments was using AWS ECS for relatively simple setup. It can be solved either with Camel or Elastic Beanstalk if you really want to sit on the AWS. So that was the most pricey experiment I had. Just taking a really big gun for a really small application is worst you can do. It's like triggering instance on the AWS and go to sleep forgetting about that. It can cause a lot of cost.
Thanks.
I'm curious because you didn't mention stuff like Fly or Render or Railway. Do you have any opinions on those services?
Not really. I haven't used them. As far as I remember, it's similar to Heroku, right? Yeah, so basically, I think it's like alternative for Camel if you don't want to configure everything manually and you really want to start off the ground really quick. I think that's the good alternative. But to be honest, I don't recall what are the prices or limitations of those solutions, but I think they are something you can consider when you don't want to get your hands really dirty with the configuration. Thank you very much.